Hello, discrete math fans. Sometimes we want to keep track of more than one variable at once. We're going to do that with a mathematical construct called a Cartesian product. The usual circumstance where this happens, the most familiar one, is when we want to mark x and y variables, such as in a graph. For example, if we write 2, -3, we're indicating a point in the Cartesian plane. The x-coordinate is 2 and the y-coordinate is -3. We call the thing with the 2 and the -3 in parentheses an ordered pair. Let's give some notation. We'll say that given elements a and b, the symbol a comma b denotes the ordered pair consisting of a and b, together with the specification that a is the first element of the pair and b is the second element of the pair. And we'll talk a little bit more about this in just a moment. And we'll say that two ordered pairs a comma b and c comma d are equal if and only if a equals c and b equals d. For sets, if we write 1, 2, that's going to be the same set as 2, 1. Recall that for sets, the only thing that we care about is membership, whether or not something is in a set. The order of the elements in a set does not matter. For ordered pairs now, it is going to matter. So when we talk about ordered pairs, 1, 2 as an ordered pair is different than 2, 1. Let's make a formal definition of a Cartesian product. Let's say that given sets A and B, the Cartesian product of A and B, which will be denoted with A and then an X and then a B, and I think it is worth noting that this X is not a multiplication symbol. It is specifically a symbol that we're using in this context to mean Cartesian product. So this A cross B is going to be the set of all ordered pairs, little a, little b, where little a is in the set big A and little b is in the set big B. We can use symbols and set builder notation and say that A cross B is equal to the collection of all ordered pairs A and B, where little a is from the set A and little b is from the set B. Let's run through a few examples. So we'll give a couple of sets. So the set A contains the numbers 1, 2, 3. The set B contains the letters Q and R. And our goal now is to find A cross B, B cross A cross A, and then we'll give a description of R cross R, keeping in mind that this R represents the set of real numbers. All right, for A cross B, we just create all possible ordered pairs where the first component comes from A and the second component comes from B. So that would consist of 1, Q, 1, R, 2, Q, 2, R, 3, Q, and 3, R. B cross A is an entirely different set where we've changed the order of the elements in the ordered pair, so we have different ordered pairs now. And we can still do A cross A. This is all possible combinations where each component comes from A. Finally, we have R cross R. We can think of this as the set of all ordered pairs x, y, where x and y are real numbers. You should be familiar with this because this is the way that we describe the Cartesian plane. This is the coordinate system that we use many times in algebra and calculus and all kinds of places in mathematics. All right, that's all for now.